everyone, I hope you all are doing well. So today we will be starting with our second chapter of coordinate geometry, which is circles. Now you will see that in the first chapter of straight lines, where we had studied a lot of formulas, a lot of concepts about straight lines and points, you will see a lot of concepts have been repeated or will be seen to get repeated in this chapter. Also, the concepts about, let's say, parametric form or tangents or chords that we study in this chapter will be again repeated when we study different conic sections, which are parabola, ellipse, and hyperbola. So again, an important chapter you need to look after. And also JEE asks at least one question from this chapter in almost every paper. So definitely a chapter to study properly. So first, let's start with by looking at what are the subtopics that we need to cover in this chapter. First, we will be looking at a few properties and looking at what exactly a circle is, a few geometrical properties. Then we will be looking into the equations of circle again, as we had studied in straight line. I hope you all remember y is equals to mx plus c. There was an equation that used to represent a straight line. Similarly, there are some equations, standard forms, which represent a circle as well. So we will be looking into those. Then a few other things about those circles. Then we will be looking at the equation of chords, mirror image, family of circles, and a few more other topics. So without further ado, let's start. So before getting into the equation or anything, let us first revise and look at a few terms that are generally used in a circle. So I hope you all know this is a circle. Again, I know my drawing is not very good, but still, this is a circle. Every circle has a center. Now again, center is represented by coordinates, which is going to be x comma y or h comma k or whatever. Now there is a radius. This is what we call our radius. And I hope you all know that if the radius is joined completely to the other side as well. Let me draw it this way. So here this is also r, this is also r. So 2r, this becomes our diameter. Diameter is basically any line inside a circle that passes through the center. So whatever line I draw through the center, that would become my diameter. And if there is any other line which does not pass through the center but it is inside the circle, this is known as my chord. Again, these are terms that you have already studied in your class 9th, 10th, again revised them in class 11th and 12th. So this is just a revision for all those. This is known as a chord. Now let's say a circle is given and there is a line that just touches the circle at some point. Now what is this line known as? Tangent. So these were mainly the basic things that you need to know about this circle. Here again, the same things have been given. There is a center, which is a fixed point inside the circle. Radius. The radius is the distance from the center of circle to any point on that circle. Now again, one more thing that you need to remember, since this is a circle, this is our center, this is our radius. Again, let's say if I say this is my arc PQ. So if I need to find out the length of PQ, how do I write it? I write it R into theta. And what is my theta? This angle is my theta. This is how generally length of arc of a circle is represented. Similarly, now you can see that if I was to take up the circumference of the circle, so what would that become from P to P? So circumference would be equal to again r theta, and what would be the theta in that case? It would be 2 pi, since we are rotating a 360 degrees, so circumference would become 2 pi r. Again, things that you have already studied earlier. A few more things, I'll just mention it here. Area, you know the formula, that is pi r square. And now let's say if I was to discuss about the locus of a circle. So how do I define the locus of this circle? you can see that all points on this circle are at r distance from the center, are all at r distance from the center. That means they are equidistant from the center. That means, how do I represent the locus? Locus is said to be points equidistant from the center. So if I join all those points that are equidistant from the center, it would ultimately form a circle. Apart from that, again, a secant is a line that intersects the circle at two distinct points. It is nothing but the same as a chord. Tangent, arc, circumference, again, sector is the region enclosed between two radii, an arc between them, segment. Concentric circles, this is an important thing you need to note. Let's say this is a circle and there is a center given. Now there is another circle whose center is again the same center that we had for the first circle. However, the radius is different. This is, let's say, R1, this is, let's say, R2. Then these two circles are termed as concentric circles. These are termed as concentric circles. After that, there is an orthogonal circles as well. We will study that when we study later. There is a subtopic on the name of orthogonal circles. Basically, it is nothing but the angle between two circles which is said to be 90. Now you must be thinking, how can there be angle measured between two circles? So we will look into that when we study this topic. So apart from that, now let us look at a few other geometrical properties of arcs, triangles, lines inside a circle. Again, these are important properties. You have already studied them, but you need to remember them because it makes it easier for you to solve questions. Let's say there is a diameter. This is my diameter. If I, let's say, from the endpoints of my diameter, if I try to form a triangle at any point on the circle, then that would become a right angle triangle with right angle at this point here. Be it at any point. Let's say if I draw the points here, this is also 90 degree. Be it on the other side, doesn't matter. The only condition that it needs to satisfy is that the endpoints are of the diameter. This is again 90 degree. Again, important point to note down. Another property, let's look at that. Let's say from any 2 points on a circle. From any 2 points on a circle, they are joined to a point on the circumference. This is the center, let's say. They are joined on the circumference. And now if I join them at the center as well. Let's say if this angle was theta, then this angle would become 2 theta. Again, another important property that you need to remember. If from 2 points I draw 2 lines which meet at a point on the circumference and they intersect at an angle theta, then those same points would be intersecting at the center with the angle twice of what the angle they were making at the circumference. Now let's look at another property. Let's say if there is a quadrilateral inside a circle. Let's say there is a quadrilateral inside a circle. This angle is, let's say, A, B, C, and D. Any quadrilateral inside a circle. So what are its properties going to be? These are again angles of that sides of quadrilateral. So what are the properties going to be? We can say that A plus C would be always equal to 180 degree and B plus D would also be always equal to 180 degree. Again, these are two important things that you need to remember about any quadrilateral, be it a square, be it a rectangle, be it a parallelogram. Again, quadrilateral is a four-sided shape. So any four-sided shape inside a circle would have these properties. The sum of alternate angles is equal to 180 degree. Let's look at another property. Let's say if this is my circle. Again, another important property I'm going to discuss. This is my center, and let's say this is a chord or secant inside a circle. These are the endpoints, of course. And let's say if I drop a perpendicular on this line. This is a perpendicular. I hope you all remember when we were studying straight lines, we had studied this concept. If there is a straight line and there is a point and we drop a perpendicular on that line, so we can find out the distance of a point from a straight line. We had studied a formula for that. Now let's say if I drop this perpendicular, this chord will always be divided into two equal halves. So basically this is a perpendicular bisector of the chord. Let's look at a few more other properties. Let's say if this is a circle, this is a tangent that passes through. This is my tangent. And here is my center. Now if I join this point at which it intersects the circle with the center, then always the radius and tangent would be present at 90 degrees from each other. Another property, let's say if there is a circle, there is a point outside the circle, and from this point, let's say I draw two tangents. One is this, which intersects at this point, and another one is this, which intersects at this point. Let's say this point is P, it intersects at M1 and it intersects at M2. So from this I can say that PM1 would always be equal to PM2. Now this is another property. PM1 is always equal to PM2. The distance is always equal if from a point two tangents are drawn on a circle. Another important thing that you need to remember. Another last geometrical property that you need to remember. Let's say there is a circle given, and let's say if I form a triangle inside the circle, and at this point a tangent is also drawn. I'll draw the diagram once again. It does not look very... Let's say this is my triangle inside the circle and there is a tangent that passes at this point on the circle. If this angle of the triangle is theta, then this angle can also be called, would also become theta. If this angle is beta, then this angle would also become beta. Again, another important thing that you need to remember. Basically these two are alternate angles, so they become, of course, equal. Again, a property that we had studied in our class 10th. So that was all about the geometrical properties and the basic terminologies of a circle. Now we will be looking into the standard equation and the different forms of equation of a circle.